All right. So welcome everyone to Sue's talk on Kotlin, Coroutine Flow, and on Android app development. So Myat is senior Android developer at Lomotive, a startup based in Singapore, a Google developer expert for Android, and a WTM Women Techmakers ambassador. Sue is a proud Myanmar programmer and passionate Android developer with over 6 years of experience in software and mobile development. Previously, she led the Android team at WaveMoney, one of the top 100 fintech companies in the world, and leader in mobile financial services in Myanmar. In her free time, she enjoys picking up new technologies. Sue is dedicated to develop, implement, and adopt new technologies in order to maximize development efficiency and create innovative mobile applications. So welcome, Sue.
Thank you so much, Sing. Okay, so today we're gonna talk about the Kotlin coroutines on Android app development, and I will talk about the common partial. I will start to talk about the common partial use case for React streams on our Android application development, and you will learn about Kotlin flows, where we can use, and how to write using the flow for reliable application. I will present using a simple application that will dive in and have a look at the basics, getting from API calls and local storage to our UI only using the Kotlin's flow with LiveData, ViewModel, and the repository pattern. And after this talk, you will see how flows enable writing, saved, reliable, how it can strengthen your Android application development. Okay, let's talk about before we dive into the Kotlin flows, let's warm up with the React streams on Android. So what is the React stream? It's to provide a standard asynchronous stream processing with non-blocking blood pressure. So what is the common particle use case on Android? Making a network request, accessing the internet storage. Both of them, we need to work on the background thread because we don't want to block the main thread, okay? These two are common partial use cases on Android application. So what are the powerful tools for kind of React streams? So there are two, RJava and Kotlin coroutine flow. Yes, RJava is very powerful. They have many features like observables, singleable, flowable, completable, but it's steep for learning curve. However, flow is easy to use, easy for implementation, and it's used coroutine internally. And yes, doesn't have some of features like RJava has, but the coroutine already implement using the React string specification, such as like RJava. So why flow? Okay. One of the reason is that you cannot use JVM specific libraries like RJava in Kotlin multi-platform projects, but Flow is a part of the Kotlin language, so it's ideal to use in Kotlin multi-platform projects. Also, Kotlin Flow has fewer operators, but they are much simpler. A single operator can handle both synchronous and asynchronous logic since the block of code that operators accept can be expanded. And Kotlin Flow is interoperable with other React streams and coroutine. Since it's built on top of coroutines in a combination with the expanding functions, it's produced a simple, reliable, and understandable API. It also supports back pressure out of the box. So before we dive into the flows, let's study a little bit on what's exactly back pressure. So I'm gonna show you with a video, which is perfect example of back pressure. I grabbed this this perfect example from using this article. Below you can see the link. If you wanna know more about the back pressure, go there and check it out. It's a really cool article. So it's time for movie.
Either. All right, girls. Now this is your last chance. If one piece of candy gets past you and into the packing room unwrapped, you're fired. Yes, ma'am. Let her roll!
So this is easier. Yeah, we can handle it, okay? Listen, Ethel, I think this... I think we're fighting a losing game. Here she comes.
Fine, you're doing splendidly. Speed it up a little!
Okay, all right. So yeah, speed it up. So she's actually trying 2 different ways of dealing with it. Setting some aside to get it later, but buffering, and eventually she's started eating, holding them in her like head everywhere. And yeah, this is a perfect example. So, all right, what it will be the definition. So, back pressure is when the progress of turning that input to output is resisted in some way. The simple answer is the input is coming in faster than what can output, or reading is faster than writing. So, okay, so we knew a little bit about the back pressure, reagent streams, and common particle use case reagent streams on Android app development. What is the powerful tool for the reagent streams? And we choose the flow rather than the RAJava, ideally to use in a Kotlin multi-platform project. Okay, so next. Okay, Kotlin flows. So what is a Kotlin flows? Kotlin flow is a new string processing API developed by JetBrains. JetBrains built Kotlin flows on top of Kotlin coroutines. It's an implementation of the reagent stream specification and initiated whose goal is to provide a standard way of asynchronous stream processing. Okay, why flow? Why not channel? There are two ways you can deal with streams or data in coroutines: the flow API and the channel API. Channels are a synchronization primitive, whereas flow is built to model streams of data. There are factory for subscriptions to streams of data. Channels can, however, be used to back a flow. Can flow give you more explicit contracts and operators than channels. You cannot lead results with flow because it automatically chooses the string due to the nature of the terminal operators, and which trigger the execution of the streams of data in a complex successfully or expectationally depending on all the flow operators in the in the producer side. And for the channel API are still in experiment. Okay, what's flow? It's based on suspending function, and let's talk a little bit about on Coroutine. Coroutine saves apps from callback here by giving up the possibility to run asynchronous code if it was asynchronous. Flow takes this step further by adding streaming to the mix. The main goal of Coroutine is to simplify asynchronous work by getting rid of callbacks, and flow emits the value sequentially. So you will learn about the flow builder, basic flow builder, and a flow operator. And we use flow builder to create a new flow, and we use operators to transform flows. This is the most basic flow builder, using a flow to create a flow from suspendable lambda block. Inside the block, you declare names and assigning it to a list of names. And next, you used a for loop to go through the list of names and emit each name after a small delay. And the flow use emit send values to consumers. There are other flow builders that can use for an easy flow declaration, flow off to create flow from a fixed sets of values. And you can convert various collections and suspensions to a flow using sflow. Okay, what about the Kotlin flow operator? So there are two operators in the flow: intermediate and terminal. So in intermediate, we have map and filter. Map transforms each value to another value. For example, in here, map transform name to name.len. And filter for filter operator, it selects values that meet a condition. The condition is length should be less than 5. So it's how maps and filter worked. Map transform each value to, as I told you, map transform each value to another value. For example, firstly we have get inside the get value we have a white, black, pink, blue, red, and then we would like to transform from names to their length. So we use the map operator, and after the filter, we filter select value that meet a condition which is below 5. The operator execute only when you invoke a terminal operator on the final streams. So finally, we will get a result is like 443. Okay, since collect is a suspending function, it's only be called from a coroutine, and then we use the ram blocking wrap function for that one. And for like how collect works, so as you start collecting values, you got when at a time, and you don't block while waiting for a new values. This is a collect work, and it's tied to deep stripe in application development. So you can see full code using the following link. So I created a simple application in Git. You can check them out if you want. Okay, this is the simple application architecture. So this application follows the Google Recommend Architecture Guide, in which helps separation content to reduce the boilerplate code. And the purposes of application using the application, follow the application architecture is to be reusable and testable. Application will load the data from network and network or a cache, and we use a flow for one-shot operation, suspend functions where a better fit, and we use LiveData for communication between views and ViewModel. And we use Coroutine flow for the repositories and data source. Yeah. So we use LiveData because to expose LiveData expose the data to observers and aware of what those observers are. So this is a very convenient way, since it will share a single underlying subscription to a flow and will manage subscription based on the observer's life cycles. Okay, so I will start explain by using started by data source. Okay, the data layer of an application is responsible to provide data, usually by reading data from database or fetching the network. So here I'm going to show you fetching the data from network. I use a retrofit for consuming the REST API, and we don't need any additional dependency because retrofit supports suspend function since version 2.6.0. And now retrofit version is 2.9.0, and we don't need to say retain observables, singles, florables, completable, or maybe like Java, we don't need it. We only need the suspense. Add suspend function and retain what we desire object. Coroutine supports in run for one-shot reading and writing since run version 2.1.0 now 2.2.5. Run version is now 2.2.5, released in October 14. And there is another things like run version 2.2 have supports for observable reads with the flow. So you can write them like remove your suspend and in front of the list of movie, just add the flow keyword, and which will observable reads with enable you will get the notification of changes like in your database. Okay, so repository. Once we have our flow in the piece, and we use editing by using the flow on here, and we use the emit function to emit the value we are expected. And here I would like to point out on the flow on. It's the only way to change the contents of a flow. The flow on operator that change the upstream content, and inside the brackets there have a dispatchers.io. So this is designed for offloading, blocking I/O text to share pool of thread and optimize for disk and network I/O of the main thread. For example, like database, reading and writing files and networking. So we use dispatches.io, and they have another thing like default. And typically, execution in Coroutine is ran in the same thread. And there you go. Repository now executes an API calls and executes the locate database and kind of event, which is like loading, and error, and we'll send the values to the UI objects on the IO thread. So all handled through flow. Okay, there could be a couple of options in our ViewModel for handling our handling flows. So we have a repository that returns a flow, but how we handle the data and push it to our UI. So we're gonna use the LiveData, expose data to observer and aware of what those observers are. And there have two, mutable LiveData and LiveData. We're gonna use the LiveData because we don't want to modify outside of the ViewModel class, and we only went to modify from like ViewModel. And push a value to retrieve the data through the repository. I used flow as LiveData extension function to convert flow to LiveData. This is very convenient since it was shared a single underlying subscription to the flow, and will manage the subscription based on the observer's life cycles. Moreover, like LiveData also keeps the most recent value for late coming observers and subscription added across configuration changes. That's cool, right? And we just push data from our API call all the way to our LiveData to observe in our UI. Awesome. We are handling data and pushing multiple values to the UI, and UI will update. UI will update, here I'm gonna share about like LiveData. LiveData has a configurable times out, and which means you can adjust the time it's take until the code block within the builder cancel where there is no active observers anymore. So keep learning. As a summary, you learn about the Kotlin flows, where to use, and then getting desire. We learn how like using flow with the calling the data from network API calls and local storage, using local storage. And the Kotlin flow is easy to implement it, which is suspended function, which is on top of the Kotlin Coroutine. And we learn about the application architecture. We apply the repository pattern. Now you can strengthen your application development. And thank you. I hope you enjoy. And do you have any other questions, Father?
Great, thank you, Sue, for the lovely talk. We're now taking questions, so if attendees have any questions, feel free to drop it in. I do have one question from when the video was playing. I was just wondering, why on earth were those people on the chain making? I can't tell. Are they dumplings?
So which one?
there was a video on, this is a silly question, but you showed a video of people making something on a on a conveyor belt, with a conveyor belt. What are they making actually?
Yeah, like they are trying to handling the like on the example is like firstly they can handle it because the coming the thing is like quite slower. After the more faster and faster, they cannot handle it. So example is like the example would like to show it's like reading. It's like more faster than the like writing. So writing, which is like they are packing the cake, and reading is like it's coming a long way. So I also really love this sample, and which is point out from the Medium article, and then I really loved it because like they when they started coming, and then final of the movie click, the ladies comes in and she'll speed it up. Like after this speed it up, they cannot handle it. Like it will be thrown away and hiding somewhere like that. Yeah, so there's a kind of example of the back pressure, and then like which is related with the re-registering. So re-registering is like to give the synchronous operation without NAND blocking back pressure. Yeah, not losing the data with somehow way. Yeah.
See. One thing, I actually don't use Kotlin. I use Go, and we do have Go routines there. So, and I feel like this is something quite similar, right? So I wanted to ask for Android Kotlin coroutines, like is there a limit on how many threads that can be created, and how do you have to measure that?
Measure that? What would you like to know about the Coroutine? You want to know about Coroutine? Yeah.
Kotlin, Kotlin's coroutine flow. That means the Android phones themselves will have to create a lot of threads, right? To one for each coroutine or something like that.
I see. Yeah. Coroutines are actually it's not thread, and I think it's coroutine as it's like jobs, and each job may contains time jobs. Let's say I wanna call the network API, and then I would like to receive at least 3 states. It's like the API is buffering now, or the API is we already receive our value, or after that we fail somewhere, like network exception or something like that. So we wanna know these 3 states, and then those things we need to run like as a job. So coroutine expanding function help like kind of things, sort of things. And like each job, and like let's say each job contains a time jobs, and jobs can range in like any thread. And currently one of the most important facts in coroutine is like coroutine can run in a single thread with the multi-chain jobs. And because like we need asynchronous because like when we are reading a file from local storage and calling the data from the local storage, and buffering the data from network, so those things we need to use that asynchronously. That is why we are focusing on the re-registering. So Kotlin coroutine supports the re-registering to provide asynchronous stream processing. So yeah, all things are relatively, but the Kotlin many coroutine can exist and be running in a single thread. Like, so we are not calling the only one API on a page, in Android application, like we can call this like at least 6 or 7 API, and when API have a kind of three or 4 events emit, we would like to emit, and in Android view we would like to call them the API using the background thread. So it's like they have like 7 thread, and inside the thread using the jobs. Each of API have 3 jobs at least, and 7 and we are running in the background, so like that. So and yeah, I have another one that is like it's automatically clean up after we call the after we finish the like test. It's automatically can help for the cancellation, but like in previously we used the RA Java, so that when we have to make our for the cancellation the thread, like those are like expensive, and those are like still using the user like user battery, because like calling the API, and yeah, you still using the yeah, battery and net like yeah, battery, so like that.
Just wondering, because it's running on a phone, the phone only has limited processing power, right? So is there any way to like limit the amount of coroutine that you would the application would be able to generate, if that's the
Yes.
so there is a way to limit the number of coroutines.
Oh, numbers of coroutine?
Yeah.
Oh, you mean the like results of using the coroutine? There is a limitation.
Yeah. Is there like a say you cannot have more than a certain number of coroutines?
No. So it will be the deep dive conversation about the coroutine, and there is no limitation, I guess. And then you can use the like results, like it will handle, because of the coroutine have the suspending function. Suspending function is like somebody is doing in a thread and somebody will wait, and after that this job was finished, it will continue the next next job. So it's like when we have a 700 job, so coding will firstly work on the first job. After the first job was finished, it will continue to the second job, like that. So it will manage like that. So yeah.
Okay. I think that makes sense. Yes. If there are no questions from the attendees, I think that should be it. So thank you very much, Sue, for the lovely talk once again on Kotlin. And and we'll see you next time.